Fractions involve proportional reasoning, and proportional reasoning is about multiplication and division math. So we need to find factors or multipliers that make the proportions equivalent. Here I have a proportional statement, and I have people in groups A and B, and A and B ratio is 5 to 11. And because fractions, numerator and denominator is important, the direction of your proportion or proportional comparison is important. So A to B is 5 to 11. So I have to make sure that I do it in the right order. Now it doesn't actually matter if A is on top or B is on top, but once I've set A on top and B on bottom, I need to make sure that the rest of my comparisons are going to be in the same direction. So it says, how many people in group B if 25 are in group A? Well, 25 goes on top then, because that's the proportion for group A. And then I'm trying to solve for the number of people in group B. And with proportions, I can use an up and down multiplier. Okay, this is a unit rate. Now that number is not the greatest number, but I could do that. Or I can use a left and right multiplier. This multiplier is much easier. And to find the multiplier, I divide the two numbers. So 25 divided by 5 gives me a 5. So my multiplier is times 5. Then I use a times 5 on the bottom. That means that my x must be 55. So I can set up my proportional equation, or my ratio can be set up as a proportional equation or equivalent fraction equation. So it says here, what percent of the totals in group B? So to get the percentage, I need to compare B to all. So if I'm going to compare B to all, I'm going to have 11 on top. All would be 16 on bottom. And working that out, that gives me my percentage. If I want to do this as a proportion, I can just divide the top divided by the bottom to get a decimal percentage. I can make this proportion of 100. So dividing 11 by 16, I get my multiplier. 11 divided by 16. This multiplier works out to be 0 times by 0.6. Work that out. 6,875. So then I use that same multiplier on the other side, times by 0.6875. So that being a decimal percentage, when I do that calculation, I just move the decimal point over 2 positions. So we're talking 68.75%. When we're doing these percent calculations, we can use our proportional equation. So 18% compared to 100%. We can just set up our proportion. The 77, we just have to decide, is it the part or the whole on the bottom? And in this case, the 77 represents the whole amount. There's my decimal multiplier. Okay, my top up and down multiplier is my unit rate. It's also my decimal multiplier. It's also my decimal percentage. So I can use that decimal percentage to solve for x. So 18% of 77 works out to be 13.86. And we can do this as a multiplying problem as well. So some of you guys are better at this and can do this as a times problem. So we can say that 77 times the decimal percentage equals the amount that we're looking for, x, which we work out to be 13.86. Now with this, really just matters, it just means we're going to either times or divide by the decimal percentage. So how do we know if we're going to times or divide? Well, if we don't know, there's lots of ways to figure it out, but if we don't know, we can always set up the proportion. We can see in which direction we're going. So a good example is here, where we have 25%, so I'm going to write my decimal comparison, my decimal proportion, and 44 is 25% of what number? 44 represents a part. Okay, 44 goes with the 25%, and so the bottom is what we're looking for. My up and down multiplier is my decimal percentage, or my unit rate. Since it's a bottom to top multiplier, but I really want to go in the opposite direction, I'm going to divide by that 25%. So in this case here, let's just solve for x first. X works out to be 44 divided by 0.25, and we get 176. And if we want to show this as a divide problem, we can say 44 divided by 0.25 then gives me my answer of 176 as my whole. So if you have a strategy that keeps this straight, whether you times or divide, that's perfectly fine. Again, this is much more reliable. If you're not sure, we can always put it into a proportional equation and determine the direction of multiplying or dividing. Our multiplying factor that we worked out here was going from bottom to top. Therefore, if we want to go from top to bottom, we use the opposite operation.